Raz, dwa, trzy. Raz, dwa, dwa, trzy, trzy. Raz, dwa, trzy.
My name is Gerd, and I work for the education application support team and for the B in Bagna, in the headquarters, which is where the factory is. Our department is in charge of, well, we do all the support stuff, events like this, we do beta testing, alpha testing, we do a lot of things surrounding the technical side. And for me as an ex-sound engineer, it's quite good because I can play with always new toys. I always say, well, there's a couple of downsides to that too. When you have new loudspeakers all the time, all the pins are still very tight, so it's never easy. But first of all, before we start, I'd like to encourage you to ask a question as soon as you have it. Don't wait. Interrupt me as you like. I'm happy for you to interrupt me. And just out of interest, does everybody here understand English? Yeah, is it good? Okay. Please, if you feel I talk too fast or something, please slow me down, say so. I have no problem with that. And so today's option, apart from, of course, congratulating Consput to their 30th, which I think is tomorrow, is it? Or is it the day after? Tomorrow? Yeah, I'm here to introduce to you the SL series from DNB. Some people might know it already, others might not. We call it a family. I've decided not to play the song We Are Family because I don't actually like it that much, but it is a family of speakers, and it is it has large speakers in it, smaller speakers, and everything you need to do it. Where does it come from? The two dads behind it, Matthias and Fiat, they always said it almost drove us nuts, which is it's a British saying, it makes me crazy. And it started off really with market requirement and expectations. So when the likes of myself or the Consput guys or all of us, when we go out there, customers tend to talk to us. They say, oh, well, we want maybe, we want this, or this could be better, or this could be different. And it's always interesting to make sure you take note of these things and you improve the next series that comes. And so what did people in the market say to us? They needed a box that does more SPL. Well, it's like cars, right? The faster. And I wanted more low LF headroom, of course. People always want more bass. Yeah, I call it the unhealthy relationship with Channel 1, but some people might also ask for all of this, ideally very light and small. So it fits in a small car and you don't have to lift so heavy. I mean, I'm past 50 and I don't want to lift a 100 kilo speaker anymore. Those days are over. Sometimes I still have to, but we think it's important that a loudspeaker has a accurate dispersion control and over the entire frequency band. And we're going to look into that, how that's achieved at a SL series. And shows have changed. We do different events now. Shows stadia are played in 360 degrees, which means you are closer to the stalls, closer to the balconies. So you need to achieve bigger up angles, bigger splay angles to get to the audience. So we had to look at rigging options and logistics and handling package. I was early on talking to some people. We've decided to come up with a whole cable series to run this system for various reasons, not only because we think they should all be the same, but it's it's often the case that systems on their own maybe do arena shows, and then every once in a while on a stadium show you need to rent some stuff in from somewhere else, and it's good to know that it's all the same and compatible. So then we usually add the DN bits, the sort of stuff that comes up when we sit at the fireplace and drink beer or do things. So let's have a look what those could be. DNB has a very long history in making cardioid subwoofers. Passive ones, which is something we do in a patented method, that's one of those. And there's a great amount of experience in creating cardioid pattern control. And that was supposed to be part of it. We wanted the low frequency output of large drivers, but maybe we didn't want large drivers. So that's an interesting one. We can discuss that later, we will. As I said earlier, shows are changing, so it sometimes happens that you don't have enough space, and anybody who's ever rigged a J-series in the Caterpillar method knows it takes quite a lot of space to do it, and we wanted to reduce that space. And we came up with the DNB array side, which is first laser and inclinometer that has a temperature sensor and a humidity sensor in it, and it's networkable. So, is that me? I think I'm holding the aerial and then it drops out, my fault. An interesting thing is water repellent fabric. So, not so big of a deal on a subwoofer, but in the past, colleagues in tropical areas have noticed that the foam we are using to stop water from getting into the cabinet sometimes disintegrates because of the humidity. The biggest problem with that sort of stuff is that you can have you would have to make a decision if you wanted to have a waterproof speaker or a good sounding one. You can't have both. It doesn't work like that. So it was important for us to create fabric and that is acoustically transparent but water repellent. So high frequency goes through, and they managed to do that. It's quite incredible. So, what is a KSL? So anybody who speaks a little bit of German will know the GSL means großer Speziallautsprecher, means large special speaker, and K means kleiner Speziallautsprecher, which means small special loudspeaker. And the Link and the SL series has it's no mistake to figure out that our factory is very close to Mercedes, and they have an SL series, so we had to have one too. So, anyway, however, the KSL is also a highly flexible standalone system, and it operates and will work in the J series application range. With a little improvement, it does a 10 degrees play angle as opposed to 7. So there's the first improvement. Easy to see, and it also of course works as a fill and a delay system to the GSL, the large system. Okay, it needs to have adequate overall headroom, and we're going to talk about that a little bit in a moment when we talk about the different drivers and what they do. But one thing was a must, it had to have full broadband directivity. So let's have a look how that works out in weight. 60 kilos, it weighs exactly the same as a J. So no difference there. It requires the D80 amplification platform, and only the D80. Nothing else will do, I'm afraid. And it's a complete package, and it's exactly the same package as you know from the GSL series. It's just smaller. So just imagine you take everything, put it in the washing machine, wash it too hot, and it comes out a little bit smaller. That's exactly what it is. So let's have a quick look at our line array history. So before 2005 the Q series came out, and there's one thing that repeatedly happens with DNB is DNB makes a loudspeaker and people use it well beyond its specification. So they do much bigger shows with our stuff than we ever anticipated them doing. So you can see we have something for more or less every application size, from very small to now very large with the GSL, and the KSL sits in that range there. So it's exactly J series territory, and for us to do a product that can do that, it had to be fundamentally different and better than a J. So let's have a look. Now, if any of you guys go and buy themselves a ticket for a rock concert, or pop concert, Madonna, AC/DC, and you stand there, you think it's great. You think it's art. You think it can't possibly be loud enough. Can't possibly have enough bass right there. If you're my grandma and you live here, you think it's noise, and it's really, really annoying, and you don't want to hear it. And the idea is now to sort of make both of them happy in an ideal world. So, and for this to become real, you have to have full bandwidth directivity. That was an outdoor example. Here we have an indoor example. Now imagine you sit there, right there where it's sort of red. It's a football stadium in Germany. Now in the high frequencies, you will hear this line array. Right? In the low frequencies, you hear all of them. Why? Because they are all, at the low frequencies, they're the same volume behind them than they are in the front.
But Gert, I would say, if you are addicted to channel number 1, like all of us, you can get the key jump 27 times with the different... 8. In this case, just 8 times. So it's always better to have 8 times the key drum than only 1.
No, that's obviously not the case. What happens is the arrival time is different. Most people know, hopefully here, that the sound is quite slow actually, compared to light. 340 meters per second. And so you don't hear all the bass drums at once, you hear them one after the other. And that causes what we would call interference, comb filtering, all sorts of nasty effects. And railroad emissions mess up the sound. So you don't actually get a good idea of a tight sound. Besides, all of this, if you're actually right under it and in the middle, there's so much bass on stage, it's unbearable. It's very not pleasant. So, how can we do this, and how can we identify what the actual problem is? In order to make a new speaker, you need to identify the problem first. Otherwise, there's no point making it, right? So here we look at a J8 isobar. Does everybody here know how an isobar works? It's quite simple. So you have here a 0, and that's the 0 axis. This is the on axis. So if I was a loudspeaker, the laser pointer is now on axis. It's pointing there. And then you can have 180 degrees this way, and 180 degrees this way, horizontal. And if you measure the volume of each frequency at those axes, you can get this isobar plot, and it shows, this is why it's called a J8. The minus 6 dB point of a J8 is exactly at 40 degrees. So it goes 40 degrees to the left and 40 degrees to the right. That makes it a J8. However, as soon as you go to the lower frequency, so somewhere at 200, it starts to open up. And at 80 Hertz, it's 360 degrees, the same volume all around. Yeah? And this area here, was identified as the area of trouble. This is when people call up and say, that concert over there is too loud. That's the frequency range they talk about. It's 2.5 octaves at the lower scale. Nobody ever hears 8,000 hertz in 5 kilometers distance. This is what they hear. And that's what's annoying them. And that's also what's messing up your sound when you're in a reverb in space. When you have a lot of reverb, when you come into what they call a boomy room, you know, you close a flight gate and it goes poof. That's a problem, this area. So let's have a quick look on how we're going to adjust that and why and how we're going to do it. In order to control low frequencies, you have very few options. One of the options is that the enclosure that's producing that low frequency needs to be larger than the wavelength it produces. Right? That's one of those classical things. So a subwoofer that creates 100 hertz, and I want to be in control of those 100 hertz, that means I want to have directivity, would have to be 3.4 meters big. That's not so good, because it doesn't fit on the truck and it doesn't go through the door. It's quite unhelpful. So let's have a quick look what we do with the GSL and why we're doing it. So first of all we start, GSL has 3 HF drivers in it with a 3.4 inch voice coil, and the KSL has 2 in it. We discussed that in greater detail. The mid frequencies are 10 inch on the GSL and 8 inch on the KSL. And front firing low frequency drivers is 14 inch and 10 inch. But then we have some extra ones. We have the low frequencies on the side. And I want to show you how they work like that. So, this is how an SL box looks in the cut view, and why did we do it like that? Let's have a quick look. So, if you actually look at the distance between 2 loudspeakers, and this subwoofer is actually a prime example for this. You will hear that later when we're outside. If you take 2 loudspeakers, 2 subwoofers, and you space them a quarter of a wavelength apart and you delay one, you can have a following effect. You can have, if you look at the microphone on the right, so the rear firing speaker leaves the loudspeaker cabinet first, and then the second one adds to it, because the sine wave meets the other sine wave right at the perfect moment. And as they do, they create more SPL to the front. If I now move my microphone behind this loudspeaker cabinet, this subwoofer for example, works exactly like that. What happens is the rear firing leaves first, the front firing leaves later, and arrives exactly at the same moment where it reaches 180 degrees phase shift, or full cancellation. Easier said than done, right? So we have to the front addition, more volume, and to the rear, less volume. That's perfect, because that's what we want. Because remember, we cannot make a 3.4 meter big subwoofer. We have to make it smaller. So, how does it technically work on a KSL or on an SL? And we have to remember what we just saw, that drawing was one frequency only. Could have been, I don't know, 80 hertz or whatever. And we are talking about 2.5 octaves. So we want to do this a little bit better than just one tone. Okay? So anybody who's ever used a J-series will know that the ports of a J-series, so the bass reflex holes, are on that side. They've now moved to the inside. There's a good reason for that. In a bass reflex system, what happens is the low frequencies of the bandwidth, the very low frequencies, they only come out the ports, this one and this one. And the higher frequencies of that band pass come from the cone, from the driver itself. So when I look at an SL series, so the rear firing speaker comes up, to the front I have an addition, and to the rear I have a attenuation. So that's the higher frequencies, that's the higher octave. And the lower octave, since it's only coming out of the ports, that's why the ports now have moved to the inside, so we can increase the distance to the railroad's ports. And the same thing happens, and you can see that the curve they take is also a little bit bigger. The interesting thing is the longer the wavelength, the larger the curve it is the wave takes. It's a bit, compare it a bit like higher frequencies driving a car around the corner, and lower frequencies is a bit like driving a truck around the same corner. You have to take a little bit of a bigger turn. And when you work this out together, you can get to this point. So here we go, back to our J8. Remember, we identified this area as being the troublemaker. And with the caloid system in an SL series, we've now created this one. So you can clearly see that the low frequencies here open up only at about 80 Hertz to about 80 degrees or 160 degrees, so they match up with the subwoofers, the SL subwoofers. That's why it's done like that, but you can see there's a lot of level loss here in the low frequencies, and I'm pretty sure you will hear that later too, when you're out there. Okay, so that's a GSL 8, and that's a KSL 8, and that's a bit different, but it's a smaller enclosure, so that's why it looks slightly different. Interesting it gets when you look at a fixed frequency. Look at 50 Hertz. This is one of our noise calc simulations. Has anyone here done one before? Noise calc? Okay, so you can see a single cabinet from the top, and we've created the same reference point with the same SPL. 50 Hertz, 130.2. Don't know where the 0.2 comes from, but it's there. And you can see that a J-top radiates quite a lot of audio at 50 Hertz to the rear of the cabinet, and the GSL doesn't. That's the whole point. Does that make sense so far? So the whole point of this is, of course, why? And doesn't low frequency directivity cause headroom? So we all know the classical CSA stick that we used to do with a Q-sub. 2 or 3 subwoofers facing forward and one firing backwards to create some cancellation. The one that's firing backwards was not necessarily adding to the SPL. It was actually just helping with the rear ejection. So how does that work in a SL series? It works slightly different. And here's a coherence plot, if you know ring ring. A coherence plot works in a way that it detects the addition and subtraction based on time arrival. And you can see here that the coherence in the lower frequencies, was that me? Oh no. So this is the lower frequency range. There is no dip in there, which indicates that the side firing speaker completely adds full to the front side speaker. So it adds full potential and reduces full at the back. So it's quite a tricky thing to do. Let's have a quick look at the benefits we get from that. So, as you can imagine, I like to use the example of a lamp. If you take a power can, right? Let's just take a normal power can and put it up there and switch it on. Everybody here will be brightly lit. And if you take a profile lamp instead, you can have maybe 2-3 people lit up and the rest is still dark. And that's eventually where we want to get to in sound. And so if I have no sound coming out the back of the speaker, it cannot hit the wall behind the stage. If it doesn't hit the wall behind the stage, it cannot create reverb. So it's reducing the boom in a venue. Makes new friends in monitor world. It's a choir to stage. Well, you can argue with this. We've heard stories of people saying it's not loud enough on stage, no? I go, you know what, for the last 30 years with front of house people had to suffer your complaint about too loud. No, just get yourself some bigger side fills, sort it out. But at the end of the day, of course, a quieter stage is easier to play if you're a musician. You know, it's easier, you can easier hear, it's better so you don't have low frequency masking. And yeah. How do you get a guitar player to slow down? Put notes in front of them. So they have a wider usable coverage. So the plots we just saw, the isobar plots, we call them isobars. The isobar plots, that line I was showing you, the 40-degree line on a J, that's the -6 dB point. And it's chosen, the -6 dB point as a coverage definition is chosen because that's where the sound broadband is 6 dB quieter than on axis. And that's typically in the industry the defining number. When they say, okay, the -6 dB point, that's what the box does. And now we don't have low frequencies coming off the side anymore from the cabinet that mask up the high frequencies. We actually have broadband -9 dB points, if you like. So we'll show you that later. Easier horizontal arraying. Now, when you hang a loudspeaker and you hang another one next to it, and you need to have even coverage, it becomes evident that a loudspeaker like an SL series that has a wider usable coverage area, you might, on a 270 system, you might be able to do it with just 2 hangs as opposed to 3 maybe. Let's see. And of course you have much less of excess noise emission. You know, that grandma that lives over there, she might be just a bit happier when you have not so much Slayer coming out of that side. There's actually a really funny story from, anybody here heard of the Reading Festival? The Reading Festival in Britain is quite famous, and it's north and south side. But it takes place more or less in the city center, which is stupid. But anyway, it's in the city center, and right at the gate where all the trucks come into the stage and stuff, right at the gate is an old house, so I don't know, 400 years old. And an old lady used to live in there. I don't know if she still lives there. But she would always complain about the music, and they would always go, we buy you a spa holiday, whatever. Go away for the 3 days and you'll be fine. And she just said, no, I don't want to go, I'll stay here. So they had to come up with all sorts of designs. This is 10 years ago, longer than that. And so the council guy and the guy from SSE, they sit in their living room, drink a cup of tea. And they said, well, we've changed the sound design, everything's going to be great now. It's going to be amazing, you have no problems. And the woman goes, yeah, great, thanks, yeah, a cup of tea, so, you know, old lady, cup of tea. And then Slipknot come on stage, and that was the end of it. And they said, basically they just walked out and said, oh, okay, we'll see you in court. And we tried to actually stop that. So, another one of the SL series, another big point was, why do we actually need more headroom and where do we need it? And other people say, I need more SPL. Really? And why? So, anybody here heard about array processing or technology? Yeah. If you're aware of it, array processing has a few advantages to it as far as distribution of level is concerned. So what you see here is you can see a direct sound versus distance. So here's a distance plot, and you can see the 8 kilohertz is losing SPL quite rapidly compared to the 125 hertz. If you're aware of line array technology, you understand why that is. And in array processed, we would like to be it like that. Because what we actually want is we don't want the relationship between the high frequencies and the low frequencies to be different. And I'm not talking necessarily volume here, I'm just talking about how it sounds. The tonal balance, as it's commonly known. Now in array processing, we can actually go pretty straightforward and we can take low frequencies and redistribute them. Redistribute means if I have too much in the front, I can put it somewhere where I don't have enough. How do we do this? It's very simple, very straightforward. We do that with frequency-dependent delay, commonly known as FIR filters, I guess. In the high frequency, that doesn't work. Because in the high frequencies on a line array, the effective length or the amount of loudspeaker you hear, even at great distance, is very small. So it can be 30, 40 meters away and you only hear 2 boxes out of 16. So between the two boxes I could shift some energy from one to the other. Well, that's pretty pointless. So what we need to do in the high frequencies, we need to have more horsepower. It just needs to be able to do more. That's it. Just more oomph. How is that done? Well, DNB had decided that the next cabinet, the large scale, or the GSL, is a 7-degree box. It should have the same display angle capability as a J series, and therefore the height of the cabinet was limited. That's how much we could do. Then, in order to increase the SPL in the high frequencies, you can do 2 things. You can use a louder driver. That's if you find one. We couldn't. Or you use more drivers, 3 in this case. So that's why it has a 3 times 3.4 inch diaphragm HF section. Now, if you use 3, then of course the physical height of this array is big, and we had to be smaller than we were. So a little bit of a development started. So people looked at what angles we can do, and then so Machmas, that's Swabian for this is how we're going to do it. And here are some of the attempts. So here you can see the original voice coil that I wanted to be, 124 millimeter voice coil, not too big. The diameter of this driver is too big. So they started to cut something off. You can see on the right hand side, top and bottom. When you cut it off, it doesn't work really balanced anymore, and it starts to deform a little bit. I'll show you a little graphic in a minute. And we ended up with 114 millimeters, which was exactly the height it needed. And by doing that, we had to basically go back to driver design and put the magnet of the HF section on the inside of the voice coil. Typically on an HF section, on an HF driver, the outside is the magnet and the voice coil is on the inside, and on the GSL and KSL it's the other way around. And that meant that we could increase the length of the voice coil to 3.4 inches, even though the driver is actually smaller than it was before. Okay? Now, here you can see on the left hand side, you can see the displacement. So on the top you can see a driver that's displaced, and that's the one to cut corners. So you can see it's not actually fully radiating evenly. So all the blue bits, with every movement it does, the blue bits don't do anything. And in the bottom you see one that is doing a lot better than that. Much more even, so you get a bit more SPL out. Another slight advantage of designing your own HF driver is you don't need a phase plug anymore. You can bolt it straight to the waveguide, which you can see here. And that makes the waveguide nice and short. A lot shorter, which also, as you pointed out.
Yeah, if it's the shorter is the HF horn and HF section horn, the less distortion you are getting out of the system.
Distortion in an HF driver is actually typically a vibration from the horn material. So that's why really good horns are typically quite heavy and big and cumbersome. Yeah? And that leads us to the next one, which is the midsection. So in the midsection, a new horn was designed. And that's actually a lie, it wasn't a new horn. For us it wasn't. It's the idea, the original horn idea, midsection horn that we employed in the V series first, in the V point. That's where it was tested, and here you can see the bracing of the horn on the inside. And the idea here is that this horn has this 8-inch driver or 10-inch driver attached to the back, and it goes left and right next to the waveguide. It allows us to have a smoother transition between the high frequency and the mid frequency. It also creates a dipole for horizontal directivity, so the distance is of course carefully chosen. And we use a new driver that has an integrated back volume. So the space on the back of the driver is fixed and it's included into the driver design. That way, this whole assembly can live inside the cabinet without actually taking away any volume of the low frequencies. So what does it all do in SPL? Let's have a quick look. That's a J8 on a burst measurement. So we take a sine wave and we measure 170 millisecond bursts, little, quite nasty little sounds, and we see when the limiter kicks in, and that's where it stops. So you can see each of these steps is one of those frequencies, and they are good to determine how loud a system goes. And you can see that a GSL is across the board a lot louder than a J series. Okay, and you can see, especially here the low frequencies, 100 Hertz and below, it does quite incredibly more. Those are the values if you interpolate it and calculate it out. So we managed with the extra shorter waveguide, the larger voice coil and the third driver, we managed to get 4 dB in the HF section. That is exactly where we wanted it to be. These two are bonus. They were not necessarily needed, but having is better. Yeah, having is better than needing. And the low frequency, of course, 9 dB, that was up down to 45 Hertz. That was quite an incredible achievement by the guys. So here's a GSL-A, and here's a KSL-A in comparison. So you can see it's pretty broadband, 3 to 4 dB as a target, less, which it does, but compared to a J, you can see it behaves very accurately like a J, apart from the low frequencies where it has substantial amount more. Funny enough, even though it has smaller drivers, correct?
Yeah, that's the point where I would like to ask you to demystify some myths which are existing in our industry sometimes. Like sorry for all the ladies, but it's one of the myths which says that size matter. Maciek, is that true that size matter? Or you doesn't know? Or we are approaching the very not safe areas, maybe going with that discussion. But in fact, sometimes the people says, the 8-inch system is not enough for outside for open air production, or the 10-inch system is good for some jazz, but not for the big rock and roll in arena. And then I think we need to point very clearly two things. The one thing is that there is a coupling effect. If you go to the line array theory, the more sources you couple together, the more low mid energy you are getting. Therefore, all the manufacturers, they are providing some special kind of filters which brings those too much energy at this level a little bit down if you coupling the filters. And another thing is that the low frequency is more dependent because of the volume of the cabinet and not the transducer itself.
Volume, you means the size of the space inside.
So sometimes I'm asking the people, have you ever seen the subwoofer which is on the size 20 centimeter by 30 centimeter by 40 centimeters? No, because to get the low end you need to internal volume. You need the big size to get the space inside the cabinet. So please let us know how it works really. What is important to get this low end from the system?
Well, there's a couple of things. First of all, you can deploy various methods, different methods. So unpassed designs, base reflex designs, all of those. Ooh, that dropped out. Wow. But you also have to always remember that the people who make drivers, the RCFs, the whatever they're called, JBLs and the likes, who make loudspeakers, they have not been sitting there for the last 20 years doing nothing. So they've been designing speakers, and we use some high tech in those. It starts with the material of the voice coils. So you have material that is less recipient to impedance change as it heats up. So you don't get a power compression as early as you previously would have. So nowadays, a 10-inch driver, for example, out of the V series, can easily outperform 12-inch drivers out of the older systems, easily. And you'll hear it in a bit when you hear some. You can, and the excursion has a lot to do with that. And the large driver is not necessarily always the better choice, because what happens on a large driver is when you get to the wavelength that is shorter than its diameter, it will start to become narrow, more narrow at the front. So if you did 15-inch speaker has about 900 hertz, so anything above 900 hertz will become directive and very uncontrolled. So if you heard a 2 kilohertz tone out of a 15-inch driver, you'll probably hear it only in about 1 or 2 degrees. And then you can't horn load it, and it becomes really difficult to operate. So cone area is a different story. If we have more cone area, we can create more low frequency. Well, that cone area could be, as you described earlier, could be 20 10-inch drivers as opposed to 10 12-inch.
Yeah, guys, look for Ampeg. Ampeg reach just 10-inch, 8 times or 10 times 10-inch, and a lot of low end because of the capacity of the cabin, because of the volume.
We have a couple of things coming up as well when it comes to subwoofers here, and I explain a few more things about that. But for example, for the moment, let's just have a quick look at the amplification. So if you want to amplify a line array system that has array processing, you have to individually amplify each loudspeaker. Right? So that means it's quite a lot of cable logistics sometimes. If you had a 4-way active cabinet, you would have to use quite a lot of cabling in order to get to that. So it's an NL8 per box. We were very happy to see that the guys managed to keep the SL series a 2-way active. So it only needs 2 amplifier channels. And the way they do that is quite clever. So channel 1 does the low frequency drivers only, because that's what needs all the power. And then channel 2 does the side low frequency drivers, and it does the mids, and it does the highs. So on the GSL cabinet, that's 8 drivers on 2 channels. That's why the GSL doesn't link through. There's no link out, because you can only plug 1 box in and that's it. On the KSL, it's a bit different. So yeah, we use a passive crossover, of course. On the KSL, we can link the system because it's a smaller box. It doesn't need as much power. So we have some reserve in the D80. So in array processing mode, with array processing, as usual, the KSL top will use 2 channels of D80, just like a J series does. Exactly the same. As a matter of fact, you can use the same cabling and the same amp racks, no problem. Oh, so there's a line missing here. That's interesting. Oh, sorry. Something has disappeared. So, if you link it, you can have 2 KSL8 or 2 KSL12 on 1 cable. So you can see the patch panel has a link out. 2 boxes. 4 ohms. Okay? And that means you cannot do array processing. So, size does matter. That's a big PA. Oh, that would be a big speaker. That's a J series by default. That's how big a GSL is in a relationship to that. It's a bit bigger. And that's how big a KSL is in relationship. So a KSL is a little bit smaller, a little bit more compact than a J. And you can see it doesn't have the same cabinet height. And that's why the KSL became a 10-degree box. It was possible to have it up to 10 degrees. Oh, I thought there was a question. So here are some dimensions. It's exactly 1 meter wide. I love that. Even I can remember it. Finally. So let's have a quick look at some rigging and transport options. Update our current... Oh, that's a different PowerPoint than I had earlier. Great. So we wanted to update our 3-point rigging. We wanted to have more up and down tilt. So on the SL series, you can take the flybar and rotate it, have it front. So you can change the center of gravity, so you can get, sometimes I think, up to 20 degrees upwards. It's probably possible. And we wanted to have compression and tension rigging mode. So tension rigging is the one we used on the VY and J series. And we also wanted to have a compression mode, which allows you to fly the system in a straight line. And we wanted to have transport for 4 tops. That's what people in the market always says. We want to have it on dollies, 4 high and 3 subs maybe. We wanted to create the array side, which we've done, which is an interesting one. It's the laser pointer that people have on top of a line array, and it also includes the inclinometer, so you can read out the angle of the top box, and also it includes temperature and humidity units. Why is that important? Well, when we do array processing, we can now do very accurate compensation for weather influences. So we can say temperature and humidity changes are much more easy to repair and fix. And the loudspeakers that are mostly affected by that are the ones that have to go the furthest distance, which are the ones that are on top of the line array. So your temperature at the front of house tower is not a good reference value for measuring that. It's much more important what the box is on top. So now with array side, we have that up on top of the speaker system. Yeah, of course, all the rigging parts, chains and lifting gear need to be in a package, which we have. And efficient system amplification, rack and cabling. So I'll show you the cables later, they are down there. They're really quite nice. Okay, let's have a look at the tension and rig. So that's the tension mode, that's the mode we all know. What happens is as the line array goes up, the hook picks up the angle pin, which is plugged into any of these holes, and then the second pin does the safety of that same method. In the compression mode, the whole array goes up straight, in a straight line, and only when you complete to build the array, you pull up the tension in the back. You can pull up this bottom fly frame and lift it up and compress it. You could also use the compression mode kit that we provide, which is a hand operated motor, which is the one we're going to demonstrate later. And yeah, there you have your array. Compression mode before and after. The good thing about this is when you're on a festival stage and you only have limited space, you do not use more footprint than the actual PA size to fly it. Okay, here's a little video and it shows it. Yeah, that's the compression mode. Ta-da! We can calculate this all in ArrayCalc, of course. David will show us a little bit afterwards. Quite important. And how to do this. Here are some of the parts we sell. So we now have the aiming plate. Aiming plate is cool if you have a really large distance to cover with your motors, if it's a 25-30 meter high ceiling and the rigging is not possible to be very accurate. You can now do it with 3 motors, and then you can steer the array in its horizontal axis by pulling on either of those two. The array will then move. Okay? The good thing is on the SL series, all the rigging hardware is exactly the same. It's just a KSL one is smaller, that's all. But if you know how to fly a GSL, you know how to fly a KSL, and vice versa. Okay? Here's what the array side looks like. That's the sender unit here. It has the little laser and everything in it. That lives in the fly frame on top of the array. And that's the hand readout unit. You need this to configure it for the network, and also during installation of the array you can read out your angle and you can switch on the laser without having the amp racks going. And then once you got amp power, you can plug the same laser into an OCA, power over Ethernet port on the front of the amp rack, and you can read all these values out on your R1 file. And this is quite useful when you want to do changes. So when you do a big festival and at 9 o'clock it starts to get dark and it gets cooler and the atmospheric conditions change, you can recalculate your array processing with these values you can read out and then load them accordingly when you have completed that. Here's the transport stuff. So it's a compact and tension card, the compression set case, and the array side connection on the fly frame. Oops, I went too fast. KSL compact cards, here are the 3 cards available. GSL only has 1 card. The KSL has 2 different ones. It's worth mentioning that these are 60, that means they do 4 wide in a standard European truck. So, but before I let you go for a drink and we have a listen, quickly let's talk about subwoofers on the subject of size matters. The new SL sub is a triple 21-inch subwoofer. And now you go, well, you already got one. You already got the infra. Yes, the infra is a bit big. Doesn't load so well in the truck. And why? Because it needed the extra volume to create the low frequencies. This one is reduced in size, so it works quarter pack on the truck or 2 wide on the dolly. We have changed the voice coil. The voice coil is now multi-layer. It's got 4 layers of the same voice coil on top of each other, and because of that we could reduce the magnet size. The magnet is now a lot smaller, and because of that it's lighter. So this box weighs 138 kilos as opposed to 154 or so of an infra. And not only is it lighter, it also is capable of running higher frequencies, and you will be pleased to hear that later on. But what does an SL sub actually do, performance-wise? So if you look at a blue line here, that's a J sub, or a well-known J sub, a triple 18. And then you see the J infra, which was a sort of auxiliary subwoofer that we were offering for people who did like raves and dance music, to be under the J sub. And if you deploy them correctly and you do everything according to the handbook, the resulting frequency response is the green line. That's both of them together. That's if you did it right. Okay? Some people didn't, but most people got it right. And in comparison to that, you can have a look at a single SL sub. So you can see it's a little bit reduced in the higher frequency. We do that because we have more low end coming up from the main boxes. But in general, you can say as a rule of thumb, 1 SL sub is the same output as 1 J sub and 1 J infra together, minus 1 dB. So it's effectively 2 boxes in one. So a quick look at the pattern control. SL sub used to have, or J sub and J infra had a button that called the hypercardioid, so we could change the cardioid pattern. So if we were flying it, we could make it to a hypercardioid and increase the directivity a little bit. That was easily done by a little bit of different EQ on the rear driver and a little bit more different level. On the SL sub, the guys managed to get it as good as you could possibly want it as for a cardioid, and I could go into details how they did it, but it's quite complex. And so it's no longer necessary to have an HCD button because, well, it's good for both modes as it is now. Here are the subwoofers on their wheel boards, but you notice they also have wheels on the back. So just in case you want to transport them differently. Poland gets cold, so buy them some jackets. Right? So here we have a product photo, fancy shot, a little bit more. I think I have some slides enabling technologies. So interestingly, when DNB started in 88 or so, not 88, but the first box, the 1220, that had a significant pattern control was the 1220, and that started at 800 Hertz upwards. At the time, that was a massive achievement. That was incredible, and we managed to get this down to now 45 Hertz. So we set the entire audible bandwidth. We used following technologies on the way to get to SL series. One of the biggest one was the E80 platform when that came out. After that, we had the OCA protocol, the new network protocol, that enabled the exchange of the amount of data that was required to operate them proper. Array processing was a direct result out of that. Noise calc was also a direct result out of array processing, and so forth. It keeps going on. But at the end, it all plays together. So, check in for updates. slseries.com if you want to. And here are some pictures. I go through them quite quickly. A couple of things we did during field testing. That's what my department does in the summer. When there is a new series coming, we go out and we do these gigs. Classic open airs, more classic. Corporate events, wrong football club, so I'm going to go really quick about that. Rock and roll open airs, larger open airs, and smaller open airs, and so forth. We do all these different events. Here's an interesting one, the Love Fest. We did a noise calc prediction for the Love Family Park. This is on JV series in 2018. You can see how the area here, down here, which is living area, is still quite polluted with noise. And if you do the same festival with the same configuration and just use KSL instead, you can see how much quieter this whole area becomes. I go back and forth a little bit. Yeah? So here is a little bit of a scale on the side so you can see what levels we're talking about. And this is a really important thing in Europe nowadays. In the future you will have festivals that will not be granted permission anymore because they create too much noise. So everybody is really wisely asked to stick to noise control and learn about it. And noise calc's free, and it enables you to do very good, accurate predictions. So help yourself and use it. So here are some basic packages. So that's a KSL fill package, which we would use maybe as an outfill for a GSL system. And this is how it would look on a European truck, on a 45-foot trailer. Barely the dance floor full. Here we have a KSL basics package. You're going to say not enough subs. I know that's what everybody says. But that's the recommendation ratio. And in a minute you'll hear why that is. So that's the amount of truck space this will take. And then we have an arena package. I don't know, 10,000, 15,000 people indoors. That could look something like that. Almost half a truck. And then we go for the big festival or open air festival package. That's a big system now. And look at your truck, a 45-foot trailer, everything's on wheels. Stick a couple of desks at the back and a mic case, and you're good to go. You can start the event. All right? Any questions? Good. No, it's not good. Well, this could mean two things. You either don't want to ask, or I explained everything perfect. So I'm an optimist, so I think I explained everything all right.